the function f of x, which is equal to x cubed minus 3x squared plus 4, has derivative f dashed of x, which is equal to 3x squared minus 6x, which is equal to 3x times x minus 2, and second derivative f double dashed of x, which is equal to 6x minus 6, which is equal to 6 times x minus 1. Sketch the graph of this function. Okay, so when they say sketch, they want something that shows where the function is and what the right shape is. And shape would be when it's increasing and decreasing and concave up and concave down. And so I'd need to draw the correct shapes for those and mark all the points where it switches between them, which would be the turning points and inflection points. And those turning points and inflection points would happen when the first derivative is 0, that'll tell me where the turning points are, and the second derivative being 0 would tell me where the inflection points are. And they've been helpfully factorized, so I can figure them all out without doing any working. And the increasing and decreasing would happen when this is positive and negative, and the concave up and down would happen when this is positive and negative. So I need to just write down where everything is positive and negative, and that should tell me where everything's concave up, concave down, increasing, decreasing, and then I can draw the graph. So I'm going to draw some diagrams, they're called sign diagrams, which will tell me whether things are plus or minus. A sign diagram for f dashed x will show the person reading it where f dashed x is positive and negative. Now, according to the factorized version here, it'll be 0 when x is 0 and when x is 2. And now I need to know when it's positive and negative. When x is something over here, it'll be, well, let me pick minus 1. 3 times minus 1, which would be negative, and this would be minus 3, so it's still negative. Negative times negative is positive, so that'll be plus. If I put something in here like 1, 3 times 1 is 3, 1 minus 2 is minus 1, 3 times minus 1, that'll be negative. And then a nice big number, maybe like 100, it'll be 100 and then nearly 100, so that'll be plus. Okay, so it goes minus, plus, minus, sorry, plus, minus, plus, and this would be increasing because the first derivative is positive, and this would be decreasing because the first derivative is negative, and this would be increasing. Okay, so I already know it goes up and down and up. That's good, and that is the shape I expect for a cubic. Now let me do the second derivative. Okay, so these are the x's, and this is what f double dashed of x is. So that's 0 when x is 1, and then everything on one side will be positive and everything on the other side will be negative. So when x is less than 1, so say 0, we'll get 6 times negative 1, which would be negative. And when x is more than 1, say 2, we'll get 6 times 1, which is positive. Okay, so this must be concave down, and this must be concave up. And when I look at all of those zones, there's 3 points involved, 0 and 1 and 2. And so I'll do one diagram with all of them. So this first zone before 0, it's increasing and it's concave down. So increasing, concave down. And in this second zone between 0 and 1, it's decreasing now, but it's still concave down. And in this third zone between 1 and 2, it's still decreasing, but now it's concave up. And then over in this last zone, it's now increasing and it's concave up. So increasing concave down is like this shape, decreasing concave down is like this shape, decreasing concave up is like this shape, and increasing concave up is like this shape. Okay, so now I have everything I need to draw the shape of the graph. The only thing I need is to know exactly where it is, and so it's very useful to say the exact locations of all of these points. I'm guessing it's going to go like this. So I need the function values at these places. So f of 0 is 0 cubed minus 3 times 0 squared plus 4, which is 4. F of 1 is 1 cubed minus 3 times 1 squared plus 4. 1 minus 3 is negative 2, plus 4 is 2. and f of 2 is 2 cubed minus 3 times 2 squared plus 4. Now 2 cubed is 8, 2 squared is 4, so 3 times 4 is 12, and 8 minus 12 is negative 4, plus 4 is 0. Okay, so I can now locate where exactly all of these points are where these shapes change over. So let's see. So 1, 2, 3, 4. 0, 4 is that point. And then 1, 2 is that point. And then 2, 0 is that point. And we know it's increasing concave down here and decreasing concave down here and decreasing concave up here and increasing concave up here. And there's a x-intercept there, I'm sure, but it probably doesn't really matter in order to locate exactly where the graph is. So this is the graph of y equals f of x, based on all that information.